Okay, this is our code base. We have run the backend on our Docker is up on the local system, and the front end is up on the local system. Then we'll call the local host on port 3000. Now this is a RetroMind AI application. This is the onboarding page where you have the instruction on what the user needs to do, upload your vehicle photos, and you have a vehicle classification section. Then we have deviation analysis, battery and wiring optimization, then the compliance report. So on getting started, you sign in, you go to sign in. If you have not signed up as a user, you can come to the create account page and sign up. Since I've already done that, I can now come into the sign in page and sign in. Okay, signing in here, you can see the dashboard. You have RetroMind here. You have the new assessment section, the history, the analytics, knowledge graph, setting, and admin menu. We can see here that the first three on our new retrofit assessment, the first three upload is the side view. Okay, I open here to upload my vehicle. And go to upload the left side as recommended by, upload the right side, upload the rear view, upload the front view of the vehicle, front, upload the engine bay of the vehicle, upload the underbody of the vehicle. Now, if you scroll down, you have an option to check for the make of the vehicle. As a database for you to check for the make of the vehicle. If you are using Badger Auto or Compact ER, you can choose that. You can also leave it blank, and the AI model underneath will automatically classify the uploaded vehicle into a particular model and make it belongs to. So we have a section here for demo. If you don't want to upload for testing, most especially for the new users, you can pick any. We have about 5 of them here. We have Badger, that's a 3-wheel Badger. Then we have a 3-wheel Badger, heavily modified. Then we have a clean candidate. Then we have the 4-wheel, and we also have the motorcycle. So you can start the analysis. Initializing and processing the upload to give us a full retrofit conversion from a conventional vehicle into an electric vehicle. Alright, this is done. We scroll down, we have 85% confidence that visibility that vehicle can be successfully converted to an electric vehicle. This is the digital twin model of the vehicle, the 3D model of the vehicle. Then we come down, you can see there's a 3-wheel, have been classified as a 3-wheel vehicle by Onyx. And those are the confidence, the quality, the geometry, the visibility, the completeness, classification, and the deviation certainty of. Then the section for recommendation, the underseat battery tray has been recommended. The motor section, a 4 kilowatt motor hub has been recommended. Then we have a 48 volt 100 amp controller with battery management system recommended. We have a custom 48 volt wiring harness with MC4 connectors. Then we have the structure, the framing and stiffening for battery weight. Then we have generative braking controller upgrade recommended. So underneath you can look at view your compliance report, the knowledge graph, and you can download the digital twin model beneath. But let us go to the setting page. You look at here, Onyx was used to classify. Let's enable some capabilities. Coming down to the setting page, you can see the workshop, the current workshop that is carrying out this retrofit work. You have a section for you to change your API key. And coming in here, you can toggle in and toggle out optimization, the PyTorch, use of PyTorch classifier, adaptive recommendation. You can turn on and off the free card export. Also the generative AI refinement for the zone routing for cable routes of the vehicle. So coming back here, you can carry out a new retrofit with a much damaged vehicle and see what the difference is. We can take the left side of a vehicle that had accident. We're taking the right side again, uploading the right side. Then we go to the rear view, the front view, okay. Then we go to the engine bay. Okay, even if you don't have the engine bay, we have at least the 3 that is recommended. 1, 2, 3 is compulsory, it must be uploaded. So we can now start the analysis on that particular vehicle. All right, after an accident vehicle, you can see the system is putting it as 55% confidence that it can be converted to an electric vehicle, conditionally visible. That's the digital twin model of the vehicle. We can see we have enabled the PyTorch classifier. That's the mobile net v3 model that help us to classify this correctly as a 4-wheel vehicle. These are the confidence factors, the quality, the geometry, the visibility, completeness, classification, and deviation geometry. So there are 2 high-risk registers. 2 of them are critical deviation from the OEM. We have critical delamination detected with major wheelbase deviation. We have major structural deviation detected, wheelbase also. Then the deviation, you can see we have a estimated wheelbase. We have what has been recommended plus what is the reference for the OEM. we are having 2,000 and 2,500, and while the estimated is 5,000 something. That's over 100 and something percent increment. That's probably due to the accident that the vehicle had. We have a retrofit DNA match showing that what we have done, there are previous retrofit that has been done, about 3 matches that has a similar retrofitting pattern has been recognized, which the user can go back to those retrofit to compare with what the AI has done. Then you can look at the knowledge graph here. These are the recommendations for the conversion, recommendation for the battery pack placement, for the motor, the controller. We have recommendation for the wiring, a recommendation for the structural, the chassis and the frame, and we have recommendation for the regenerative braking. So here we can quickly go to the compliance report. For the functionality of the compliance report, you have the capability to export it as a JSON or PDF. We see the vehicle classification section, a 4-wheel drive. The confidence is 38%. There was no human confirmation. The model was sure that this is an actually 4-wheel vehicle. We have alternatives, maybe probably motorcycle, unknown type, 3-wheel type, and the percentages are much lower than the 4-wheel. So we have one abnormally. As the deviation, we have one abnormally. The severity is medium. Multi-salvage, as the wheelbase, where we have a 25% increment, 125% increment. So for full assessment, we have the confidence score of 85. That's truly it can be converted. Then we have quality. Equality, this is already shown in the main assessment area. Then we have the critical risks. We have 2 high risk problem, which the recommendation is made here on what the workshop needs to do. The compliance state is false, not exactly complying to the OEM. So the overall recommendation, we have 6 in here, the same thing as what we have looked at before. For the battery placement, we have the recommended sizes of the battery pack and the computed zone that needs to be installed. We have the engine bay mount, the trunk, and the boot section. The wiring guidance has been suggested. Then the cost implication of carrying this out, the tooling that is required by the technician, and a full details of the 3D model, the digital twin data. And then we have the retrofit DNA that shows other matches that has already been done by the workshop. So you can export to PDF, export the compliance report in PDF format. Okay, heading back here, we can look at the knowledge graph. Looking at the knowledge graph, we can see other retrofit that has been carried out, how they are related to the one that we have just done. We've seen here motorcycle. So this form a database of previous retrofit that the workshop and the technician can easily access. And the system, using this knowledge graph, the system retrains or unaccumulated data every 1 hour. Once we have a sample rate that are up to 10 and above, the system will automatically retrain the AI model for a better retrofitting, for a better future retrofitting. Then we have a section for history that stores all the retrofit that has been carried out by the workshop. The identified vehicle, the status, was it completed? The compliance, did it fail or did it pass? Then the confidence level of the conversion. Then the visibility, is it fully visible? Is it conditionally visible? The date. Under here, you can quickly view back your retrofit assessment, and you can also generate reports from each of the retrofits. We have analytics section that shows you the overall analytics of the workshop, the retrofitting that they have done, the jobs that have been total jobs, the completed jobs, the confidence level of the retrofitting that has been done, the time spent in processing the retrofit. Then we have top deviations. What are the main top deviations? We have seen deviation mostly in the frame, that's the chassis of the vehicle, both in the left rear and the rear cross member of the vehicle. Another much higher deviation we have is the wheelbase. So here the analytics can show you the overall retrofitting information that you need to know concerning your workshop. Then we have the knowledge graph, as we have already shown. Then we have the settings section. You have the settings section where you manage your account and your workshop. You can create more workshop here, and you can change your API key, regenerate a new API key to safeguard your workshop. Then the optional capabilities, which are all turned on, can be toggled off here and allow the system to use the heuristic classifier and recommendation system. The section for the administration, you can come here and put in your generated API key to be able to view the overall metrics, the workshops, the users, and the audit log, and the OEM. So under development, you can easily copy this and paste now and authenticate under development. But in production, you will need to regenerate your own API key to be able to view the metrics. So we can see the number of workshops, the number of intakes that have been carried out by these workshops, the total jobs by the workshops, the completed jobs by workshops, the ones that fell, the one that time out, and the active workshop at the moment. Now these are the list of registered workshops. They are all active, the intake, the number of intake they have done, and when they were created. And we have the user base, which you can assess how many users you have. Then we have the audit log that shows at the back end what happened during all the training and the recommendation. You can go to the next page. It's a long running page. Then you have the OEM data. Here we have the manufacturers, different vehicle manufacturers in India. You can look through, you can search, then you can pick a particular manufacturer, then you see the vehicle. You can look at the spec of the vehicle. What are the major spec? We have the wheelbase specification, the ground clearance spec, the gross weight, the fuel type, the overall length of the car, the cargo length, the payload, overall width, cargo width. And we have the seating capacity, overall height, and the cape weight, and the engine volume. This is basically what a retrofit mine does, and we can show here our